Brain candy.
Hello, and welcome to another episode of Brain Candy. Now, last time we talked about what our age would be on a certain newly found planet, Wolf 1061c. If you haven't checked it out already, I highly suggest you do in the link right here. And if you have, well, then just hang on for the ride. Now, last time we encountered the problem that it's kind of difficult to define what a year is in relevance to our age. For example, you've probably heard of the Gregorian year or the Julian year, but have you ever heard of the Platonic year or Great year? But then there's also the sidereal, tropical, or anomalistic years, the Draconic year, the Lunar year, the Heliacal year, the Gothic year, the Besselian year, and the almighty Galactic year. What do all of those years have in common? Well, I'll just give you the answer. They all have a fixed frame of reference. And we're about to explore why that's a little bit of a problem when we're defining age.
The way we define age is all relative to the space and orbit you are trapped in. Your birth date doesn't so much mark a day as it does a position of Earth's orbit. But even that isn't necessarily true, because Earth doesn't travel in orbit that returns to a starting point. The year you were born is simply a numbered record of listed revolutions. I was born 22 revolutions ago in the 1993rd revolution Anno Domini, or after the year of the Lord. Yes, that's right, we all follow a Christian calendar curated from one man, a 6th century monk named Dionysius Exiguus. But why do we even use a year? It turns out it took until 1601 to even scientifically calculate this. After the death of astronomical observer and Danishman Tycho Brahe, a colleague determined that the orbits of planets were moving in ellipses, not circles. He had also discovered that the more closely a planet was to the Sun, the more quickly it moved, and the further away it was from the Sun, the more slowly it moved. Unlike his past colleague, he had the mathematical capacity to formulate these into what we now know as the 3 laws of orbital motion. It is the third of these laws that defines our year, that is, period squared equals distance cubed, or rearranged, period equals the square root of the distance cubed. This was actually calculated 50 years before Isaac Newton wrote the universal laws of gravity. He had calculated how planets moved without even knowing why. Counterintuitive but effective, and 50 years later it would all make sense. Newton came along and wrote this. As a relationship to describe the force between object masses, the reason planets moved more quickly when they got closer to the Sun and more slowly as they moved further. It is the same formula we used to describe gravity on a planet earlier. Oh, and that colleague, he had a name. Johannes Kepler. But it gets weirder. I mentioned before that Wolf 1061 was in the constellation Ophiuchus, which depicts a man bearing a snake. But there are some who say that Ophiuchus is stepping on Scorpius the snake, as a symbolic reference to the serpent in the Garden of Eden, making Ophiuchus a guardian, or a gatekeeper, let's say, to the tree of life. This interpretation was made no other than Johannes Kepler. Okay, so we know our age on Earth, and we know our age on Wolf 1061c, but we still haven't solved the age debacle yet. Our conclusions reveal that age is based on planetary orbits. But what happens when you leave the solar system? See, we can only perceive our definition of age to a pattern occurrence we already know, like the revolution around the Sun or the repeating appearance of stars. But once you leave that setting, our definition of age no longer applies. Why not? Insert Einstein's theory of relativity. Time does not exist separately from the movement of objects. The law of physics appear the same to all observers. This was supported when he calculated that the speed of light is unchanging regardless of the relative motion of the source and the observer. There is no fixed frame of reference in the universe. Everything is moving relative to everything else. There are many fun experiments where you can picture a simpler model of this, like when you're traveling forward or backward in a car at a constant velocity, you could pour a cup of tea or throw a ball straight up and down. Einstein's mathematics defines space as having 4 dimensions and not 3, that 4th dimension being time. Space-time can be compared to the fabric in the gravity models I showed earlier. It too can bend and warp. Without a sun to be relative to, our definition of age has no meaning. I hinted at this earlier when I said that at the speed of light, time stops. This is known as time dilation. Relativity's etymology comes from relativus. Relativity can be defined as to refer back to, or in relation to, or dependent on something else. But Einstein admits that he wouldn't have arrived at this solution if it wasn't for the reading of Scottish philosopher David Hume's A Treatise of Human Nature. Within Part 2 lies the ever-famous relationist doctrine, in which he argues that we perceive the world in Lockean terms as secondary quality, or grounded in mental operations. This spectator's vision of the universe is comprehended by the mind in sight and touch, wherein lies our fallacy. John Locke supports this by noting, our minds operate at a range of speeds that are fixed by the original nature and constitution of the mind, and beyond which no influence of external objects on the senses is ever able to hasten or retard our thought. We fail to see extensions not visible or tangible. If event A happens, then event B follows. With proper causality and proximity, we can assume that event A causes event B. But we fail to see the source. We have no external sensory impression of causal power when observing cause and effect relationships. All we ever see is cause A constantly conjoined with effect B. We link planetary orbits to the length of existence without really realizing the source. That is, that everything is moving relative to everything else in the universe. Revolutions have no causality on life's duration. It's not our fault that we see everything relative to Earth and its orbit. I mean, after all, that's what we have evolved under. But what happens when you don't have a sun to be relative to? What happens when you leave the solar system? Take this scenario, for example. If there was a baby, let's name him Johannes, and he was born in a spaceship outside of our solar system, and in this spaceship there was no windows to track the movement of stars, or sunrises or sunsets, when that baby finally grew up, would he know how old he was? The real answer is that he can't. There's no way of knowing his age. But what if he kept a watch of the time back on Earth? Then he would know his age. But he's not on Earth. Is the length of Johannes' existence being almightily controlled by a 2007 Casio model? Surely it is not. So how old is our specimen? There are hundreds and hundreds of debates on this topic, but the answer is unsettling. He doesn't have an age. By our definition, he can't. But just because you are ageless does not mean you are immortal. There is only one universal natural unit that truly describes the duration of life's existence.
Cellular divisions!
The real truth about birth is that you and I are giving birth right now to millions of you. You are constantly replacing yourself. In most scenarios, it begins with stem cells that grow and develop or differentiate into the cell they need to be to perform the function they need to do. Now, some cells don't replace themselves at all, like the ones in your cerebral cortex, but other tissues can be replaced every few weeks, depending on the wear and tear. We know this, of course, because of nuclear weapons and the release of radioactive carbon-14 and the predictable rate of decline. Besides your brain and heart, most of your tissues follow this treadmill-like replacement. For example, your skin and intestines. It is this reason that we can graft tissues, regenerate our liver, and to some extent have X-Men-like healing powers with cuts and scrapes. Your timeline of divisions commences after your ultimate beginning, conception. The true essence of human growth lies in the fact that you and I are radial, indeterminate deuterostomes. We all start off life the same way. That defines how our cells divide immediately after fertilization, and is essential to how we become a human, and not a sea star. After the zygote cleaves into a radial mass of 8 cells, the blastula, unique to animals, then forms and invaginates into the archenteron, which would eventually become the anus. That's right, the first thing that you ever were was a butthole. But we are triploblastic, meaning we form from the inside an endoderm, or eventually our digestive tract, mesoderm, our blood and lymph, and our ectoderm, our skin.
Still not convinced that cellular divisions are the capital T true mark of our age? Well, consider this. How old is this tree? How would I know? Hey tree, how old are you?
I'm Groot.
Well, that's certainly not going to work. But most of us learned at one time or another that a cross-section would reveal the tree's age. Why is that? Tree ring dating, or dendrochronology, was first discovered by the Greek botanist Theophrastus in around 350 BC. Recognition of this annual pattern was later pointed out by Leonardo da Vinci in his Trattato della Pittura. Each of those rings generally represents a year because in the vascular cambium, the tree grows a new layer near the bark called the lateral meristem. The lateral meristem grows more quickly but less dense in the early growing season, but in late summer and early autumn, the wood becomes more dense and grows more slowly in preparation for winter. These are marks of cellular division. Even though they're plants, trees divide cells similar to us. Scary similar. You could compare the lateral meristem to the top layers of our skin. If we didn't shed skin, we too could cut a cross-section and roughly count our age. If our birthdays are just a position in the elliptical orbit of our sun's gravity well, and if cellular divisions are the true measurement of life's duration, then birthdays seem, well, insignificant. But that doesn't mean don't celebrate it. See, birthdays, like other holidays, are a time to be happy. Over 2 billion birthday cards are sent each year in the US alone, accounting for 58% of all cards sent. 58% of all cards are sent with the intentions of making someone else's day, to acknowledge someone's existence.
Let me see the card.
But this is no new tradition. The earliest records of birthday invitations go back to the 1st century AD by the wife of Roman commander Aelius Brachus. She sent these on wooden leaf fragments. Perhaps the origins of the birthday party evolved from pagan culture. To protect the birthday person from evil, they would surround them and make noise to scare off the evil spirits, and also to make the birthday person merry. Statistics show that as daylight decreases, people exhibit more feelings of depression and anxiety. But it dips in December. Any guess why? Holidays. Psychologists call this holiday-induced euphoria. The holiday of a birthday is a day to remind someone that they are in fact special. It is one day out of the year set aside to acknowledge someone else's significance. People in history who have made great strides in humanity aren't remembered on the day they were assassinated or the day they died, but on the day they were born. Birthdays are special, and although the birthday paradox states that if there's 23 people in a room, you have a greater than 50% chance of sharing a birthday with them, it is still a day set aside for you. See, we may all start life the same, but it is the different timing of our births that echo separate, individual, unique, lively paths. Besides cancerous tumors, the number of times your cells divide is finite, and for as long as we've known about cell theory, we've been trying to extend that. It's no surprise that we don't live forever. But your divisions have made you into the stuff you were yesterday, the mass you are today, and the person you'll be tomorrow. Your cells will always be your cells. You are you on Earth, you are you on Mars, and you are you on Wolf 1061c, and you will always be you until your last division. Perhaps Dr. Seuss said it best. Today you are you. That is truer than true. There is no one alive who is fewer than you. So celebrate a position devoted to you. Blow out the candles on the cake, because how many divisions do you have left? How will you spend them? Who will you spend them with? Thanks for watching.
Happy birthday to you. Happy birthday to you. Happy birthday.
You are constantly replacing yourself. The real Take this scenario for example. Einstein's mathematics defines space as having 4 dimensions and not 3. That 4th dimension being space. Calculated that the speed of light is unchanging. Time does not. It's not our fault that